Hello everyone, welcome to class 9 science book, chapter number 4 in CERT, structure of the atom. In this class, we will study what is an atom made up of, what are the subatomic particles of the atom, how are they arranged inside the atom. We will also study about the experiments which scientists conducted to understand all these structures. We will also be going into the detail of how a scientist thought about it that the atom is divisible. We will be wondering the physics of structure of atom. So let us begin. We have earlier learned that atoms and molecules are the fundamental building blocks of matter. The existence of different kind of matter is due to different atoms constituting them. We all know matter is made up of different types of atoms. But here are a few questions you should be thinking. Question number 1. Are the atoms really indivisible as proposed by Dalton? Dalton was the first scientist who did a complete study of atoms, and he told that atoms are the basic building blocks of all the matter. They cannot be divided further. So we are questioning that theory. Is it actually so? Question number 2. If the atoms can be divided, what are the subatomic particles? Till this time, there was no knowledge of subatomic particles of atom. Nobody knew about it. Scientists thought something which they only imagined, and then they gave certain experiments and results to prove what they imagined. So question number 3 is how these particles were arranged within the atom. All these 3 questions we will be answering in this class itself. Let us start with the notion of charge particle in the matter. For this, we have to go for an experiment. Simply comb dry hair. The comb is now able to attract pieces of paper. What is the meaning of it? The comb has some charge. That is why other charge is being attracted. On rubbing two objects like hair and comb, they became electrically charged. So the charges on the comb attract opposite charges of paper. The question again arises. Where does this charge comes from? Charge on the comb. The answer is charge on the comb is coming from the atom. It means there is something inside the atom. So the atom is not indivisible, it is divisible, and it is made up of charged particles. Let us go back into the history of science to understand about the charge of particles, how it was proposed that the atom has charged particles, and how it was discovered and a theory was given about it. Year 1886, E. Goldstein, scientist, discovered the presence of new positive radiation in a gas discharge. Accidentally, this was discovered by him. In the year 1898, J Thomson proposed that there is one subparticle of the atom. It is negative charge, and henceforward it will be known as electron. So for the first time, something which is inside the atom, subparticle, was proposed by J Thomson. At the same time, around the same year, the E. Goldstein discovered the presence of new positive radiation. That new radiations were discovered by Goldstein led to the discovery of another subatomic particle. Around the electron was discovered, proton was also discovered. The charge is opposite to that of electron and mass is about 2000 times that of an electron. So these 2 years were the major years in the discovery for subatomic particles of atom. So before we move on to this question, let me take you back to where we have given questions for thought. Question number 1. Are the atoms really indivisible? So the answer is no, it is not so. The answer is atoms are divisible. And just now you have seen there are two subatomic particles which can exist inside an atom. One is negatively charged electron, one is positively charged proton. So question 2, if the atoms can be divided, what are the subatomic particles? So till now we have studied about electrons and protons. And question 3 is what we are going to answer. How are these particles arranged inside the atom? So scientists did a lot of experiments to answer the above question. And based on their observations, certain models of atoms were put forward. Most of these theories were awarded Nobel Prize. J Thomson was the first one to propose a model for the structure of an atom. His structure of atom looked something like this. This whole atom is made up of positively charged protons and some electrons are embedded in it, just like plum pudding. In pudding we have plums. So pudding is here positive charge and plums are electrons. And the postulate given by J Thomson were: first postulate, an atom consists of a positively charged sphere and electrons are embedded in it. Second postulate, the negative and positive charge are equal in magnitude and the atom as a whole is electrically neutral. So this gives an exact result. Yes, the matter is neutral. So, but still, there are some drawbacks. Results of few experiments done by some other scientists could not be explained by this model. And he was given a Nobel Prize for the discovery of electron in 1906. And my dear children, you have to learn these postulates because this is asked in the exam sometimes. Write down the postulates of J Thomson, write the drawbacks and so on. So let us move on now to J Thomson, from J Thomson model to another model of atom where these drawbacks were taken care of. Our next model is Rutherford Model of atom. It was proposed in 1911 by Rutherford and his fellow associates. They performed an alpha particle scattering experiment. What is the experiment? Let me just give you a brief of it. Look at the diagram. Here you can see small gold foil atoms. All these atoms, which are small circles, they are in a gold foil. We are using the word foil, we are using the word gold foil here because we are taking a small thin layer of atoms of gold so that heavy alpha particles, when bombarded on the gold foil, can pass through it. Alpha scattering experiment is about bombarding the alpha particle on the gold foil and noting the result down, noting the observations. Where are these alpha particles which are being bombarded going? Are they passing through the straight? Are they getting deflected? Because as per Thomson model, the electrons and the protons, they are lightly charged particles as compared to alpha particles. So, and they are evenly spaced in the whole of the atom. So, alpha particles will be passing through it as they are heavy particles. So, let us now understand this table which shows us some expected observations as per J Thomson's model, the actual observation done during the experiment, and from the observations what are the inferences or the results, and hence the postulates of the new model suggested by Rutherford. So first observation which was expected was alpha particles will be passing undeflected through the foil as they are heavy. But the actual observation is a bit different. Not all, but most of the particles pass undeflected through the foil. Now, when they are passing undeflected, see the diagram. These are shown by the straight lines. It means most of the space inside the atom is empty. There is nothing to stop the alpha particles. So, they are moving straight. So, this is the first inference from the experiment. Most space inside the atom is empty. Second expected observation was no particle will be deviated from the path. Because alpha particles are heavy, foil has very less number of particles. And all the atoms, they are quite light subatomic particles. Now the actual observation. A few particles deviated from the path. Now this was unexpected result. You can see from the diagram here. This particle is getting deflected. Here the alpha particle is going deflected. It is getting deflected at certain angle. Now what does that mean? It means something like this, that you have a bullet, 15-inch bullet striking a paper and getting reflected back. Just not possible. So it was shocking, surprising result for the experiment. But there was certain inference coming out of it. It means there is a positive charge occupying very less space in the atom. So plum pudding model of J Thomson has suggested that the positive charges are throughout the sphere, evenly spaced inside the atom. But it is not so. They occupy very less space. And still another observation was still more surprising. Rare particles even bounced back. You can see some of the particles coming back at 180 degrees. Now what does that mean? Alpha particles are positively particles. If they are coming back, that means they are being repelled by positive charge. And if they are being repelled, that means something comparable to this is there in terms of charge. So that means all the positive charge of the atom is concentrated, and concentrated at a very small volume inside the atom, from where the alpha particles are reflecting back. If the alpha particles are striking at the space where the positive charge is there, it is getting repelled and bouncing back. Now these results gave Rutherford an idea that atom could be of different type. So he suggested his own postulates. First postulate, there is a positively charged center in an atom called nucleus. Nearly all the mass of an atom resides inside the nucleus. Second postulate, the electrons revolve around the nucleus in well-defined orbits. Third, the size of the nucleus is very small as compared to the size of atom. So quite a good hypothesis it was, but still it also had certain drawbacks. The orbital revolution of the electron is not expected to be stable. Now try to understand this one. If an electron is moving in an orbit like this, it's going on moving. So it is accelerated, and accelerated charged particle always produce electromagnetic radiation. And when electromagnetic radiation is produced by this moving electron, it means electron is losing energy in the form of radiations. So losing energy means no longer will be able to remain in the same orbit. So the size of the orbit goes on decreasing, something like spiral. Finally, the electron goes into the nucleus and the atom becomes unstable. But in reality, it is not so. Atom is very stable. So that means something is still lagging behind. Some drawback is still there. And this drawback was later removed by the next proposed model of atom. And meanwhile, for the discovery of positive charged particles, electrons, and so many other things, for the discovery of this model of atom, Rutherford and his associates got Nobel Prize in 1908. The next model proposed was by Bohr, Niels Bohr. He proposed the model of atom in 1913. His postulates were: only certain special orbits known as discrete orbits of electrons are allowed inside the atom. So atom cannot just move around anywhere, revolving around the nucleus. It has to be certain special orbits. These are the kinds of orbit as you can see in the diagram. Only in these orbits the atom is allowed to move. And while revolving, In these orbits, the electrons do not radiate energy. These are the special orbits where energy is not lost. The orbits or shells are known as energy levels. So inside we have nucleus. The first orbit n equal to 1, 2, 3, 4 means these are the different energy levels. First energy level is called as K shell, second L, third M, and fourth is N shell, and so on. So these are the few levels in an atom. It has more than such energy levels. Now this answers our third question also, that how is an atom arranged inside the nucleus? How the nucleus and the subatomic particles are arranged inside the atom. So one more subatomic particle was discovered here after the model of Rutherford. That was in 1932. J. Chadwick discovered another subatomic particle which had no charge. Yes, it was surprising. Chadwick discovered another subatomic particle having a mass nearly equal to that of proton but neutral. So it was eventually named as neutron. Neutrons are present in the nucleus of all atoms except hydrogen, and the mass of atom is therefore given by the sum of masses of protons and neutrons present in the nucleus. Let us now move on further and understand how electrons are distributed in different orbits. These orbits are known as shells. We have Bohr and Burri rule for that. The rule says, first point, maximum number of electrons present in a shell is given by the formula 2n square, where n is the orbit number or the energy level index. N can take the value 1, 2, 3 and so on. For K shell, that is for n equal to 1, the number of electrons are 2 into 1 square, that is 2. For L shell, the number of electrons are 8. 2 into 2 square is 8. For M shell, the number of electrons is 2 into 3 square. 3 square becomes 18. For N shell, the number of electrons is 32. Now, this electrons, there is still further rule for distribution of that. Second rule, the maximum number of electrons that can be accommodated in the outermost orbit is 8. After that, the electron moves on to the next orbit. Third point, electrons are not accommodated in a given shell unless the inner shells are filled. So you cannot fill in the direct outer shells. You have to start from K, L, M, N shells like this. So we have this diagram which we have seen in the beginning. Let me give you an example. Lithium, central nucleus, and first K shell has 2 electrons. The third electron is in the next orbit and the other electrons are missing. That means the orbit is empty. So still the vacancy for 7 electrons exists here, and so on. So we can see the first 18 elements here. Let me take you to aluminium. In this case, we have L shell which is filled with 2 electrons, M shell filled with 8 electrons. Now the N shell is left out with 5 electrons. It has only 3 electrons. So 5 vacancy exists in case of aluminium, and so on. So here is the diagram giving you why different atoms have different structures, different properties, because they have different numbers of electrons in their various shells. And this structure of atom, it is now helping us to understand various properties of matter. In the next class, we will continue about the valency of the atom and various characteristics of the atom. Thank you very much.